In algebra, there are some rules that just feel kind of like magic. Today, we're diving into one of them, the quotient property of logarithms. It's this super powerful tool that lets us turn a really messy division problem into simple, clean subtraction. So let's break down how it works. Okay, so to really get where this log rule comes from, we first have to rewind a bit and look at its mirror image, exponents. Logarithms and exponents are what we call inverse operations, which means their rules are perfectly, and I mean beautifully, connected. So, think back for a second. When you divide two powers that have the same base, like b to the m divided by b to the n, what do you actually do with those exponents? Right, you subtract them. This one simple rule is the foundation for absolutely everything we're about to cover. And this is where that connection really clicks. On the left, you see our familiar exponent rule. Division leads to subtraction. So it kind of makes sense that the rule for the logarithm of a division would also have something to do with subtraction, right? Let's see exactly how that plays out. And that brings us to the star of the show today, the quotient property itself. This is the formal rule that's going to unlock our ability to break down or even combine logarithmic expressions that involve division. So here it is in all its glory. The logarithm of a quotient, that's m divided by n, is equal to the difference of the logs. So log base b of m minus log base b of n. What we're really doing here is turning a tricky division problem inside the log into a super simple subtraction problem between two logs. Now this is super important. Getting the order right is everything. Here's the key thing to burn into your brain. When you have log m minus log n, that first term, m, becomes your numerator. The term you're subtracting, n, becomes the denominator. That order, it's totally non-negotiable. All right, theory is great and all, but let's actually put this thing to work. We're going to look at how to use it both ways, expanding one log out into two, and then combining two logs back into one. Let's start with expanding. Okay, for our first example, we're starting with log base 3 of 81 over 9. So we apply the property, and that becomes log base 3 of 81 minus log base 3 of 9. And hey, we can actually solve those. Log base 3 of 81 is 4, because 3 to the 4th is 81, and log base 3 of 9 is 2. So 4 minus 2 gives us our final answer of 2. And boom, it checks out perfectly. Now let's go the other way. We have the natural log of 12 minus the natural log of 4. Now remember, the natural log, or ln, is just a fancy way of saying log with a special base, the number e. Since the bases are the same, we can combine them into a single log. The natural log of 12 divided by 4, which just simplifies down to the natural log of 3. So much cleaner, right? And of course, this property is a huge deal in algebra. If we have log of x over y squared, we just apply the rule and get log of x minus log of y squared. This is a great example of how different properties can work together. In fact, that second term can be simplified even more using another rule, and that's actually a sneak peek at the power property, which we'll definitely get into in a future explainer. Okay, this property is awesome, but man, is it easy to get tripped up. Let's go over two of the most common traps that people fall into so you can totally avoid them. This first one is a big one. I see it all the time. It is so tempting to see log 10 divided by log 5 and think you can just cancel out the logs. You can't. The expression on the left is the division of two completely separate log values. Our property applies to the expression on the right, the log of a division. These are two totally different calculations, and trust me, they give you wildly different answers. I know we already touched on this, but it is so important that we've got to say it again. Order matters. Log A minus log B becomes log of A over B. If you flip the subtraction, guess what? You flip the fraction. The rule of thumb is simple. Whatever term you're subtracting, that's the one that always goes in the denominator. So at this point, you might be thinking, okay, cool rule, but why does this actually matter? Where does turning division into subtraction really pop up? Well, it turns out it's pretty fundamental to how we measure and compare all sorts of things around us. Well, here's a perfect example you've definitely heard of, the decibel scale. It's built on a logarithmic ratio. To compare how loud two sounds are, you actually take the log of the ratio of their intensities. Yeah, that's right. You're basically using a version of the quotient property every single time you talk about decibels. So let's pull it all together. With logs, multiplication turns into addition, and division turns into subtraction.
This amazing pattern of simplifying operations is what makes logarithms so powerful, which leads to a really interesting question. If that's true, what operation do you think corresponds to an exponent inside a log? We'll dig into that mystery next time. Thanks for watching.